Hello, today we're going to learn about Excel functions. Let's start with mathematical functions. The first function is ABS, which is a short form for absolute. As you might be aware, an absolute value of a negative number is a positive number. An absolute value of a positive number is also a positive number. In the formula before us, we can see total assets, total liabilities, and difference between total assets and total liabilities. Now, if I had to calculate the difference between total assets and total liabilities, I would simply go about formulating a formula to say row 11 minus row 12, which is H11, H12, I11 minus I12, and so on. Now, as you can see, wherever the liabilities are more than the assets, it gives us a negative number. But an absolute function will allow us to convert all those negative numbers into positive numbers. Now let's take a step back and understand why would we need such an analysis. Sometimes we need to compute difference as an absolute value. In such cases, absolute or ABS function is used. Let's see how the ABS function is formulated. We'll recreate the ABS function in row 15 is equal to start any function we have to use an equal to sign. Then we type ABS. Now you can see that Excel itself prompts and gives an introductory note about the function, which says returns the absolute value of a number without its sign. Now let's proceed with the function. When I press tab, Excel automatically understands that we are ready to input the arguments of the function. In the round brackets, we can see after ABS, it says number. If we put a negative number, let's say minus 20, and close the bracket and press enter, it will convert the negative 20 into a positive 20. What if we wanted to convert total liabilities minus total assets, the difference, into a positive number or into an absolute number? We go back to the formula is equal to absolute tab total liabilities total assets minus total liabilities, bracket close, and enter. Now let's copy this formula for all the cells. And as you can see, wherever total liabilities were more than total assets, absolute function helped us convert that negative number into a positive number. Let's move on to the next function, mod. A mod function allows you to give the remainder after a number is divided by another number. Can you think of a situation where that might be useful? Often, while building financial models, we need to have escalation flags or flags after an interval of certain number of years, number of days, or number of periods. We can use mod function to achieve that. Let's see in the example before us how that is done. As we can see in row 24, we have the year numbers starting from 1 to 8. In the row below, in row number 25, we have expenditure to be incurred flag, which is based on mod. The example before us wants that the expenditure has to be incurred after every 2 years. Expenditure amount is 45 million and interval, as mentioned in row 22, is 2 years. How do we go about achieving that? Mod function is divided every year in the mod function is divided by 2. Now wherever the remainder is 0, the mod function will return a 0. Wherever the remainder is not 0, the mod function gives us the remainder. Let's see step by step how we achieved it. First we start with the mod function. Excel prompts us that we are looking for the mod function. We press tab. The first argument is the number. The number we want to divide by another number. So in this case, we want to divide the year number, which is in row 24, divided by the interval period, which is 2. So I reference it from cell F22 and I convert it into an absolute reference so that when I copy my formulas across, this reference does not change. And I close the bracket. Press enter and I get a remainder of 1. Let's hold that thought for a minute. We first copy this formula for all the cells. Now as you can see, maths is at play. 1 divided by 2 gives us a remainder. 3 divided by 2, 2 divided by 2 will not give us a remainder. 3 divided by 2 will again give us a remainder of 1. 4 divided by 2, no remainder. 5 divided by 2 again gives us a remainder of 1. However, the problem at hand was to consider expenditure after 2 years, which was every second year. However, the mod function as it is gives us a remainder in the first year itself. Now we'll have to tweak that function a bit. What we do then is we apply a condition. Let's look at the first cell itself. We say mod of H24, which is 1, divided by 2 is giving us a remainder of 1, but we want it to appear the other way around. And essentially we want to inverse or flip the results as we've got in row 28. What if we say and test this function for whether it is 0 or not? Let's say we say mod H24 F22 is equal to 0. Excel says no. Should we test it for each of the cells then? Better yet, let's break this up into steps. I copy this formula here. Okay. Now we are testing the mod function to say whether it is equal to 0 or not. Since it is not equal to 0, we get a false. We want to convert this false into a 1 or a 0. So we modify the formula a bit further by putting the entire mod function as it is into brackets and multiplying it by 1. When we press Ctrl plus Enter, we get the desired result. So to recap, we enter the mod function with the divisor of 2. But we have to modify that function to delay or flip the results as to reflect an expenditure on flag at the end of every second year from 1. Then we multiply the entire formula by 1 to convert the false or true values into ones and zeros. And finally, if you look at in row 27, we simply multiply the expenditure amount to be incurred in each year by the flag that we just created in the row 29, which has been formulated in row 25 as well. This was the mod function. Let's move on to the pi function. As you might be aware, the function or the mathematical formula to calculate the area of a circle is pi r square. Excel has an inbuilt function of pi. Let's use that pi function to calculate the area based on the radius given. In the example before us, we have the radius as 5 centimeters. Let's formulate what the area would be using the pi function. I say is equal to pi. Now, as you can see, the description of the function that Excel has prompted does not ask for any argument once we tap on tab. These are two round brackets, open and closed, without any argument, which means if I close this bracket and press enter, I will get the pi value. That was the first step. Let's go back to the formula, press F2, enter the edit mode. Now I know that I have the pi value. What I want is to multiply it by the square of radius. So I select the radius. Now I need to convert it into a square. So I press Shift plus 6, which gives us the square symbol or the square operator, if you will, and 2. Let's press enter. We get the area of the circle. Let's format it and remove the decimal places. Using the pi function, we've successfully calculated the area of a circle. Just one more point to be emphasized here. Whenever you are calculating the square of a particular number, there are two ways to go about it. One is to manually square a number by multiplying the number by itself. The second way is to use the inbuilt operator, which is 5 raised to the power, and the power is the shortcut for having a square or raised to the power function is Shift plus 6 and then 2, which essentially means 5 raised to the power 2. These are two ways of finding the square of a particular number. Let's move on to the next example. This example is about calculating the sum and then a percentage of the gross profit to total revenue. Let's go line-wise. We have sales in row 43, which are manually input for ease of understanding. Then we have cost of sales, again manual inputs as negative figures. Gross profit is nothing but a sum of sales plus cost of sales. Now, since cost of sales is a negative number, we can say that essentially we are subtracting the cost of sales from total sales. To achieve that, what we did was, let's delete this gross profit calculation. We say equal to SUM, stands for sum. Press tab. Now as you can see, Excel here gives us and requests us for certain arguments. It is important to understand the syntax of a particular function in Excel. Whenever you press tab and enter a formula where you have to enter arguments, you will see certain arguments without square brackets and certain arguments with square brackets. Arguments without square brackets, such as number 1 in this case, are mandatory. The Excel function will not work without such argument inputs. When you see the next argument, which is number 2, it is within square brackets. That means that the argument is optional. So if you wanted a sum of just one number, we could achieve that by, let's say, sum of 1 is nothing but 1. The Excel formula would still work, although it is not used, but it would still work. Let's go back to the sum formula, and I want to sum the sales and cost of sales. Since cost of sales is a negative figure, it will automatically calculate the difference between sales and cost of sales, which is nothing but gross profit. So I select sales, cost of sales, and one more row below cost of sales. We will understand why we've done this, but for a moment, let's just complete this formula by closing the bracket, pressing enter, copying this formula across for all cells. Now the question is, why did we select one additional row while formulating the sum formula or the sum function? Often, while we are building financial models, we might need to add a new line beneath cost of sales. Let's say another type of expenditure. Let's say expenditure related to marketing. Okay. Now, and we would have that expenditure in a new row. I select the row, add a new row, and marketing expenditure. minus 50. Now as you can see, the formula automatically considers that marketing expense, and the gross profit is amended or reduced by the amount of marketing expenditure. However, what if we had the formula only for rows 43 and 46? So let's go back one step, amend the formula here by saying sum of only sales and cost of sales, bracket close, enter. Now let's add another line of marketing expenditure. minus 50. Oops. The formula does not consider minus 50 in this case. Why? Because we had specified only 2 rows here. When we added the third row got added before row 46, which was earlier 45. Now since our sum formula was only restricted to the first 2 rows, it ignored the new additional line. That is why it is a good modeling habit to always sum till the last blank row. so that whenever we add new line items before that row, before the last blank row, such line items will automatically factor themselves into the sum formula, the sum function. So we amend this formula by sum, select all, bracket, OK. Now there is a nifty little shortcut to avoid all the typing and all the selection and to sum in a quick way. What is that? Let's delete the formula from here. Now if I need to add up rows 43, 44 up to 45 in cell H46, the shortcut is Alt plus equal to. The moment you press that key combination, you will see that Excel has automatically inserted a sum function with the relevant referencing of rows 43 to 45. The only task remaining to be done is press enter and you have the sum function, and the sum function is complete with the minimum possible key combinations. So to recap, sum function, always try to reference the sum function till the last row just above the total or just above the cell which contains the sum function. Alt plus equal to is the shortcut to achieving the sum function as a shortcut in the quickest possible way. Now moving on to the calculations below. In the calculations below, we have computed gross margin. What is gross margin? Gross margin is nothing but a percentage of gross profit divided by sales. So if you can see, H46, which is gross profit, divided by H43. Similarly, Y on Y sales growth. Y on Y stands for year on year sales growth. We need to compute what are the sales of year 2 as compared to year 1 as a percentage. Similarly for year 3 as a percentage of year 2. The formula is purely mathematical. Since in the first year there is no comparison or there is no prior year sales or gross margin, we keep that year as blank and mark it as grey. But from the second year onwards, the formula that we use is sales of the current year, which is I43, divided by sales of the previous year, which is H43, and then minus 1. Let's break this formula up to understand how this works. Is equal to sales of second year divided by sales of the previous year. Let's press enter and see what happens. 1.1, which essentially means that sales of the current year are 1.1 times the sales of last year. In other words, we can also say that the sales of current year are 110% of the sales of last year. To make it clear, let's convert it into a percentage. Alright? Now if someone asked us, I want to know what the percentage change is, can we do that? I say we can. We know how much current sales are as a percentage of last year. But if I want to determine the percentage change, I will simply subtract minus 1, which means that current year sales are 10% more than the sales of last year, which is precisely the formula in row 49. Moving on to the next formula. Here we wanted to compute the annual growth rate compounded annually for sales. As you might remember from your maths classes, we want to compute the compounded annual growth rate. We want to see what would be the rate of growth on year 1 sales, which continued every year till the last year and gave us the last year sales value. So in the present example, we say what would be the rate applied on 7,000 and the years onwards to achieve a growth of and achieve a sales value of 11,900 million in year 8. Let's look at the formula. O43 is nothing but sales value of the last year, year 8. H43 is nothing but the sales value of the first year. We divide O43 by H43 and we get the sales of last year over sales of the first year. But we want to break it up into an annual growth rate. The formula we use is raised to the power 1 by 7 because year 1 sales were compounded 7 times effectively to reach year 8 sales.